Hello, and welcome to the Candent Technologies Navy STP Syscom TIE 2024 presentation. Our topic today is our compact electric-driven air compressor technology for aerospace applications, in particular for aircraft airflow control systems. This development work is being carried out under a Navy STTR Phase 2 contract for Topic N68335-23-C-0054, sponsored by ONR Code 35. As we begin, please allow me to give you a very brief introduction of Candent Technologies. We are a small engineering research and development company, established in 2001 in the Indianapolis metro area. Our primary focus is on propulsion and power systems for airborne, marine, and ground vehicles. Our capabilities and technology portfolio are quite broad and include clean sheet design, build and test of advanced technology, micro and small turbine engines, for propulsion and power generation applications, very low acoustic signature, high-efficiency outboard motors and thrusters for small combatant craft, and, of course, the subject of this presentation, our advanced technology, compact air compressors for aerospace applications, as well as several other technologies and capabilities that we would gladly tell you about. Now, let's talk about this STTR and the solicitation requirements that we are addressing in the program. We must design, develop, build, and test a compact, reliable, electric-driven air compressor for aerospace applications with a compact controller and no external cooling system, and compatible with aircraft airflow control systems. In addition, the design must be optimized for size, weight, and performance, otherwise known as SWaP. So, what is airflow control? Well, it is a technology where directed airflow over a control surface or lifting surface on an aircraft is used to modify and control the pressure and flow field around that surface in order to affect directional forces to control the altitude and/or direction of flight for an aircraft, or enhance the flow stability over a lifting surface, preventing flow separation, for instance, or enhancing lift. And of course, such a system needs a device to provide the necessary airflow, and that is where our solution comes in to do just that. In the next slide, we discuss the improvements brought about by the technology. The capabilities of airflow control technology could eliminate the need for hinged control surfaces, such as rudders, and could minimize the size of the control surfaces as well. So far, the most often used air source for airflow control systems has been turbine engine bleed air, which unfortunately is detrimental to engine performance, engine life, and aircraft performance. An alternative air source is an auxiliary power unit, or APU, which is a turbine engine-driven compressor, typically relatively heavy, that consumes more fuel. On the other hand, our solution is a compact, high power density, reliable electric-driven air compressor, which is actually an enabling technology for airflow control systems, as we explain next. ONR, the sponsor of this STTR project, reached the conclusion that an electric-driven compressor could be the best technology solution, and that is why they selected it as the focus of their solicitation. The electric air compressor is much smaller, lighter, and more efficient than an APU, and would avoid the use of engine bleed air and its detrimental effects. Now, the Candent solution not only addresses and meets all the requirements, but is also designed using a systems approach that optimizes the desired characteristics, in particular SWaP, as well as subsystems integration, and also takes into consideration aircraft system integration concerns. Our next slide describes the status of the program. As of March 2024, we have completed the design tasks and commenced the build segment of the Phase 2 base program effort with the focus on hardware procurement and manufacturing, which will allow us to assemble, instrument, and test the prototype units later this year. Included in these efforts are subsystems and other advanced technology hardware testing. By this fall, we should have advanced the TRL level from TRL 3 to TRL 5 at the completion of the testing. In the follow-on Phase 2 program option, if exercised by the Navy, the plan is to update and refine the design, update the prototype configuration, and conduct more extensive development testing, including simulated operational scenarios, bringing the technology to TRL 6. At that time, we should have validated the design intent and achieve the objectives and system attributes as summarized in the follow-on slide. To recap, the design objectives and characteristics of the system, as shown in this slide, have advantages and benefits that enable the aircraft airflow control technology potential to come to fruition, made possible by the optimized swap characteristics of the Candent electric-driven, high-power density advanced technology air compressor, including its self-contained cooling system. Once we have completed the program and achieved our TRL goals, the next step is focused on achieving transition of the technology to production, properly known as Phase 3. At this point in time, our technology is somewhat ahead of airflow control system implementation on any air platform program of record, although there are active research programs exploring and developing the technology. As we develop our compact electric air compressor technology, we are aware of the applicability of the technology to not only advanced future aircraft designs, manned and unmanned, but also to current fleet aircraft, particularly those that must operate under the aerodynamic effects of rotor downwash or propeller wash, and the interactions with their control or lifting surfaces. As we continue our development testing through TRL-6, the maturity of our technology should give us an opportunity to realize our flight test participation objective as we execute our transition plan and explore the market potential. Examining the market potential of our air compressor technology, in particular as an enabler of airflow control systems applications, we see no current fleet requirement or upcoming program of record requirement toward which we could point our marketing efforts. However, because of the nature and characteristics of the Candent air compressor technology, we believe that, upon successful demonstration of the hardware, the level of interest in certain programs of record will rise, and the possibilities of applications for the technology will quickly improve, as will be the case as well, we believe, with future advanced aircraft designs. In the past, Candent has worked with major OEMs in the development of certain technologies, and we continue to follow that strategy with this advanced technology electric compact air compressor. As airframers develop aircraft that could benefit from airflow control technology, Candent will be ready with solutions to enable incorporation of that technology into their advanced aircraft designs. Indeed, it makes sense for us to continue pursuing potential partnerships with the major airframers, as in fact, OEMs have endorsed our technical approach and have provided and continue to provide valuable technical advice. So, as we close our brief presentation, we thank you for taking the time to visit with us and invite you to come see us at the Navy STP Syscom TIE 2024. Our extensive experience and capabilities across several technology disciplines could be key to developing solutions that you may be searching for now or that you may be anticipating for future development. Please come see us at the event or reach out to us via the contact info provided in the slide. We are always glad to chat with you about your requirements and potential solutions and capabilities that we could apply to help you achieve success in your programs.